Hi everybody, welcome to another video in Pre-Calculus section 1.3 Properties of Function. As mentioned in the previous section, what we study here is just a review from what we have from coarse algebra or trigonometry. So the first one we have here is an even and odd function. An even function is a function for every value of every number x in the domain. The number negative x is also in the domain, and f of negative x equal to f of x. So this is the characterization of an even function. An odd function is characterized by f of negative x equal to negative f of x. The difference, of course, is just this negative. In terms of what we see here is, for example, if we have this point f of x and f of x, x and f of x, the point negative x give us the same y values. So they have the same y values. So because of that, an even function is symmetric with respect to y, the y-axis. So because we're just switching the y value is still the same on the same height, the x value will be opposite to each other. Therefore, it's symmetric with respect to y, the y-axis. An odd function is symmetric with respect to the origin. Of course, this is taught in coarse algebra and trigonometry already. Now, so of course, if we have the graph like this, that one. If we have a point here, go across the y-axis, there's nothing. So this is not symmetric on the y-axis. But if we go across the origin, there is a point across from it. So that's why this is an odd, because an odd function is symmetric with respect to the origin. So this one is odd. Now, even if we have a point here, go across from the y-axis, there is also a point on the graph. If we have a point here, go across from it, there's a point on the graph. But if we have this point here and go across from it, we do not have it. So this is not symmetric with respect to the origin. It is symmetric with the y-axis. So that's why this is even. Right. Next, this one. Well, this is not even a function. Because a function, when we have one x values, that gives us two y values. That is not a function. It cannot happen, right? One x can only give one y values. So this is not even a function. I should just say not a function. Because here we have one x values that give two y values. So it is not a function. Right. Now, determine if the following functions are odd, even, or neither. This one first, we're just going to use the definition. Definition, even function and odd function, both of them start from f of negative x. So testing if they are odd or even, the first thing we do is find f of negative x. So what we do is, of course, we're going to put in negative x into x. Right? And then we say it, negative times negative, because negative square is going to be positive. So we have 3x squared minus 5. Now this is exactly as the original function. So in that case, we say it is the same thing as the original function. Therefore, this one is even. Right. So to test if the function is odd or even, we start from f of negative x. And we put negative x in for x. Right. Negative cube is going to be negative with an extra negative here. So that will be positive. 5x cubed minus 2x. Now compare this with the original function. This is not the same as the original function. So we can say this is not even because it's not equal to original function. Now, when at this step, if we manufacture out the negative sign, what should we put inside it to make it equal? Right. In order to have positive, we have to have negative, because negative times negative is positive, right? And then we can take the negative out. That would be plus 2x. Now look at inside the parentheses. This is exactly as that. So here we say this is equal to the negative f of x, which means that the function is odd. Yeah. So that's what we have. Next, so always start with f of negative x. So I'll put negative x in for x. Right, absolute values of a negative or positive is going to be the same thing, right? Absolute of negative 3 equal to absolute values of 3. So in that case, absolute values, the negative or positive is still the same. Even power, odd to an even power, that's going to be positive. Compared to the original function, they are the same. So that's why this is an even function. Next, once again, we start with f of negative x. So put negative x into it. Negative x into x, and we have negative 2x. Negative x squared is going to be positive with an extra negative. Make it negative x squared. And they are not the same as the original function. So this is not odd, not even. Sorry. So this is not equal to the original function. So that's why this is not even. Now try to manufacture the negative sign. What could be inside? So inside, if we factor out the negative, we have 2x plus x squared. And that is not equal to the negative of the function, because the inside is not the function. So it's not equal to negative f of x. Because of that, that is not odd. If it's not even, not odd, this one is going to be neither odd nor even. So, what I want to write in the note is this. These are some common even function. Is that we have x to an even function. Absolute values of x, constant. The reason constant is even simply because if we just have, for example, so whether we have f of negative x or not, because there's no x to substitute in, is still equal to 3, right? So any constant is an even function, right? Now, more interesting, what in the trigonometric function, what is even, what is odd? Of course, we will study that and we'll review that later, but cosine is even, and reciprocal of that, secant also even. Right. Of course, when we go to trigonometry, we'll revisit this. Odd function. Odd function, we have x to the odd power, an odd root, or 1 over x to an odd power. in terms of trigonometric function, sine is odd. Reciprocal of that, cosecant. Tangent is odd. Reciprocal of that is cotangent. So those functions are odd and even. Now with that we have an important result here. The combination of all even function is even. Combination of all odd function is odd. And the mixture of both of them are neither. So let me write this. Combination of even function is even. Combination of odd function is odd. A mixture of both is neither. Mixture of both even and odd function is neither. Right. So now with all of this, we can go back and do this example rather simply. To x, we have an x, so this to the x to the first power, which is odd. X squared, x to an even power is even. A mixture of even and odd, so that's why this is going to be neither. Right, next, absolute values is even. X to the fourth power is even. Even and even is even. Negative 5x to the cube. Because the coefficient, the constant in front of it does not do anything, because we only substitute negative x into x. So we focus only the term that have x in it. The constant coefficient has nothing to do with it. So x cubed, x to an odd power is odd. 2x, x to the first power is odd. So odd and odd is odd. Right, simple enough. Right, now this is even easier. We have increasing and decreasing. The way we define increasing on an open interval is that if bigger value of x, we have bigger values of y. Kind of decreasing. Once again, we define on an open interval. If the x value is bigger, the y value is smaller. Of course. At this point, all we need to just see is look at the graph. If it go like this, of course, going up, that is increasing. If it go down, it is decreasing. And if it's flat, that is constant. And the way we write the answer, it is an open interval. Right. Now let's have this example. Let's we have the graph like this. Determine the values of x where the function is increasing, where it is decreasing, and where it is constant. So very straightforward. First, it is increasing. Increasing is where it go up. It's from -2 to 0 here. Again, the way we define it, it is an open interval. So we write an open interval, because it could be here as well, to the open interval of x. So the answer here is only go from 3 to 4. So what we write here is the x values go from -2 to the x values of 0. The x value go from 3 to 4. So we only write the open interval of x values. So that is increasing, decreasing. Decreasing is where the function going down. And the x values, that when it happen, when x equal to 0 to x equal to 3. And it's kind of difficult to see, but this part here is where it is constant, and the x values for that we only write the -4 to -2, right? So whenever we write the interval where the function is increasing or decreasing, we only write the interval of x. Right. Because this is probably the easier part of cost algebra, and definitely easy part for pre-calculus. We just go over this strictly review. Right, next, local maximum and local minimum. So local maximum is the point that is locally bigger than everything else. So if it is bigger than everything else, and we define that on an open interval containing the point. Local minimum at C, if it is on an open interval containing C, and in that open interval it is smaller than everything else, it is a local minimum. So an open interval, actually we can say open, but a very small interval. Right. So let's just go to the example. By the way, in that case, we say f of c is the local maximum values. So the values is the y values, and we say the maximum at the x values. So we will write that. So let's look at the graph like this. By the way, if there's an arrow on both ends, meaning that the function will just keep going up indefinitely. So locate any local maximum and the local maximum values. So even though the function keep going, but locally we have the maximum here, because compared to the point around it, it is the highest point, right? So that's what the local minimum means. We only compare that point to the point around it, and in that case it is the biggest one, biggest value. So we will write local maximum values, or just local max values is equal to 3, which is the y values, at x equal to 0, which is the x values. So that's why we write the local maximum values equal to the y values occur at x equal to whatever that is. Now, so that is the local max, because locally we compare a very small interval. That point is the highest. Right, next. Local minimum. This is local minimum here. If we compare to this small interval, this is the lowest point. By this interval, this is the lowest point. So there will be 2 local minimum. Say local min, or the local minimum values. The first one will be at negative. The values is equal to -1 at x equal to -2. The second one, we also have the local minimum values of 0 at x equal to 1. So local minimum values of 0, the y values is 0, occur at x equal to 1, and this is local mean. That's what we have. Right, determine whether function is increasing. Well, increasing, it's going to go from -2 to, so this part is where it's increasing, -2 to 0. So in this interval x, the y values go increasing, and also from x equal to 1 to infinity. Notice that I only write like this, and I do not write the union in between. It's different. The domain will be the union, but increasing meaning it is increasing in that interval and increasing in that interval. It does not increasing all the way. So that's why we should put just a comma here. The interval where the function is decreasing, well, negative infinity to negative 2 will be this part, or from 0 to 1. Right, pretty straightforward. Absolute maximum and absolute minimum. Now the difference here, of course, instead of local we have absolute. So the definition here is that let the function be defined. If there's a number and that value is bigger than everything else in the whole domain, here we have some interval I will be the same thing. So absolute max or absolute min we compare to the whole interval, as opposed to this case we compare to a very small interval containing the point. Here we compare to the whole domain in the whole interval. That's the difference between absolute max and the local max. Absolute min and the local min is that absolute we mean we compare absolutely the whole domain. Right. Theorem. If a function is continuous on the closed interval, then the function has a maximum and an absolute minimum. Right? So the function is continuous on the closed interval, then it guarantees to have the maximum or the minimum. Of course, if the function is not continuous, there might be a gap. For example, if we have a function like this, it does not have the maximum because this point is missing. So there's no maximum here for this function. But of course, this is not continuous. So to guarantee the function has the maximum or the minimum, we require the function to be continuous on the closed interval. When we have those two conditions, the function guaranteed to have a maximum and a minimum. All right. Now with that, let's just find the maximum and absolute max and absolute min in here. By the way, we write the same thing as what we had before. So let's say we have this point. By the way, if you look closely, this is an empty circle here, and this is a dot there. So in this case, we have the absolute max. It will be none, because even though that one is the highest, but the function keep on going. So there will be none. Because the function keep going compared to the whole interval, there is no maximum because just keep going up. And there's no absolute min either, because this point is missing from the interval. So there's no point that has the minimum values. So we also have no absolute min. Right, now, because this interval is not closed, it is not continuous either. So that's why when we have those two, we may or may not have the maximum or the minimum. Right, in this case, it is a closed interval, a two dots at the end, and it's continuous. So in this case, we have an absolute max. So the absolute max values equal to 4 at x equal to 0. And then we have absolute min here. This point is the lowest in the whole domain. So we have absolute min value equal to, that look like -4, occur at x equal to -3. Here the function keep going, so there's no max. No absolute max, but there's the absolute minimum at this point. So we say absolute min values equal to -2 at x equal to -2. So this is pretty straightforward. So this is the easier part of what we study. By the way, if you got the idea, if you got a sense that it's kind of like the isolated section put together, well, it is. We just got some in coarse algebra, some in trigonometry to put all together in one class, and the purpose for that is to prepare you for calculus 1, hence the name pre-calculus. It's just what we need to know before we go to calculus. Right. Also, this average rate of change of the function and the slope of the secant line. So actually those two are the same. If we have 2 points not the same in the domain of the function, the average rate of change is determined by the change in y over the change in x, or f of b minus f of a over b minus a. Of course, a and b cannot be equal. If they are equal, the denominator equal to 0 divided by 0 is undefined. Right. Just go straight to it. And if we have the graph, let's say we have the graph, one point is f of a and f of a, and b and f of b. If we have the line that go through 2 points, that's called the secant line. In Greek, secant comes from the Greek word means cut. So it will cut the graph at 2 points, with a and b here. F of a and b, f of b. Right. So find the average rate of change of this function. Well, that's easy. Formulas from 0 to 2, meaning that we go from 0 to 2, which is 8. Final minus initial. By the way, f of b minus f of a over b minus a, this is the same. We can also write this as equal to f of a minus f of b over a minus b, or f of b minus f of a or b minus a. The point here is b and f of b, those come from the same point, and a and f of a come from the same point. So if we gain up using 2, that from the first, and 0 from the second. Right, so that's what we have. Now this function, put 2 in it, what do we have? 2, now we put 2 in for x. And subtract where we put 0 in it for x. 2 minus 0 is 2. So 2 square 4 times 1, so that's 9 minus 1. So it's 8 over 2 is 4. Right, so again, if we use a calculator, we have 0 and 2. So 0 store into x. And we have 2x squared plus 1. It looks simple now, but when we have a more complicated example, this will come in handy. It's 1. Now we put 2 in for x. And we evaluate the same thing. And we take these values, subtract these values, divide by 2. Yeah. So of course, the calculation is simple, but the reason I want to use a calculator, just so when we have a more complicated example, it will be helpful. Next, this is the average rate of change from 1 to 2. So just have f of 2 minus f of 1 over 2 minus 1. Now put 2 in the function. And then put 1 in the function. 2 minus 1 is 1. Of course, divide by 1 is, we don't need to write even divide by 1, right? So 2 squared is 4 times 2 is 8 plus 1 is 9. 9 minus 3, so it's 6. Yeah, just write 9 minus 3. Right. So that's simple enough. Next, suppose we have the function x cubed minus 3x plus 2. Find the average rate of change of g from 1 to 3. So first we start with f of 3 minus f of 1 over 3 minus 1. So this is average rate of change. Put 3 in for x. Subtract when we put 1 in for x. Three minus 1 is 2. So 3 cubed 27. 27 minus 9, 18. Plus 2 is 20. Minus 1 minus 3 minus 4, so minus 4. So that 24 over 2 is 12. Right, I will check using the calculator here. 3 stored to x. And the function is x cubed. That is faster than time in x cubed minus 3x plus 2. And now we will store 1 into x. And then we evaluate that. Good thing we check, right? That's a plus. So this will be 0. Yeah, 1 plus 2 minus 3, so that is 0. And 20 divided by 2 is going to be 10. Yeah, good thing we check. So 20 minus 0 divided by 2, so that 20 divided by 2 is 10. Right, so that is average rate of change from 1 to 3. And that is also equal to the slope of the second line from those 2 points. So first thing we said, slope of the second line from x equal to 1 to x equal to 3 is average rate of change. Average rate of change for the same for x. I usually prefer using pencil, but writing pencil is difficult to see in this camera, so I may use this more often than I want to. Right, so slope of the second line is the same thing as average rate of change on the same interval from 1 to 3. So in this case, the slope is equal to 10. And the equation of the line with slope equal to m is y minus, okay, with the slope equal to m at x equal to a is y minus f of a equal to m to x minus 8. So this is the equation of the line with a slope go to the point x equal to a is that. So now after all of that, we have y minus the values. We have the values f or g, doesn't really matter. In here at x equal to 1, the values of the function is equal to 0. We did that. x equal to 3, the values of the function equal to 20. So we can use either one of this. And let's use the 20. The slope we calculate is 10, and x values is 3. So multiply it out, we have y minus 20 equal to 10x minus 30. Add 20 on both sides, y equal to 10x minus 10. Yeah, just minus, add 20 on both sides. So that is, of course, if we're using the 3, if we use this point. Now, if we want to use the other point, y minus the values is going to be 0 equal to 10, the slope x minus x values of 1. So we have y equal to 10x minus 10. Actually, this one is even similar than that. But the point here is we could use this point or we could use that point, because those 2 points on the line and that second line. And if we have the slope and we have the point, then the equation of a line is given by that equation. Right. So at this point we focus on is that the slope of the second line is the same thing as the average rate of change. Of course, from the same interval of x. And with that, I stop section 1.3 here. Thank you for watching. See you in another video in pre-calculus.